Hello and welcome back to our presentation on the lasagna project. In this video we'll talk about the technical development that we did during this first period. This is, brought to you by the Logic Analyzer. This is an invaluable tool that we use to debug our implementation. We debugged everything from pins to protocols, and it's been absolutely necessary for where we are now. So the first thing that we did is to add support for Bluetooth, and then we also added support for LoRa, but let's talk about Bluetooth first. It needed a preliminary addition to RiotOS in that the board has 3 SPI buses, but Riot only supported 1. So we added in a pull request support for SPI 2 and 3. Our chip uses SPI 3, and this is now included into Riot itself. We then started to interact with the chip. We tried to use the Nimble BLE stack, but unfortunately this proved to be a task that was too big to handle, and it was not worth the time since the chip is already relatively old and doesn't support the latest protocols. So we decided to stop, backtrack, and move to a different implementation. So we decided to port a library that was meant for Arduino to RiotOS. This meant updating all the API calls and doing some more modifications. In particular, the library was interacting with SPI in an interrupt handler, but Riot doesn't support this interaction, so we had to rewrite the ISR and a separate thread to provide this interaction with the chip, in a sane way for Riot. This is our first communication, just to provide some context, and on top you can see the SPI bus, which transmits all the data necessary for chip initialization, and the reset line as well, so you can see all the interpretation of the data. This took a lot of work to get to this point, but it was absolutely worth it. Now the chip works. And then we also had to add support for receiving packets. Our library only supported the beacon role at first, but we also need to be able to receive packets on the Bluetooth shield that you can see. So we added this support by using the STM HAL, yes. And now we can fully support the receiver role, so that we can then handle all the packets that we need for our system to work.
So, welcome back. Let's talk about a little bit about LoRa. At first, we tried to make the LoRa shield working. We figured out that we had to use a variant of AT with custom commands, and the only documentation available we found describes the last firmware version, but of course ours was older. Here we have an example of our communication between our motherboard and the shield, and the LoRa shield over serial port. So, modifying the AT driver, we managed to communicate with the shield, and we could even start a LoRa join procedure. Finally, we success to forward the message to TTN, and then TTN does not success to receive any packet after the join accept procedure. This is madness? No, this is LoRa. At the end, we tried a different board which natively support Riot, and it used a modern version of LoRa, which was the 1.0.2, and it is supported by IoT Lab. Now it's demo time. In our demo, we will show few things. In particular, we will show our receiver and our beacon, and we can see how there is a jumper between the analog 1 and analog 2, which is needed for the activation of the chip select, and then we have the beacon on the bottom. Here we have a serial output coming from the receiver, and we can see easily the LoRa joining procedure, but also the BLA joining procedure, and some data parsed from the BLA packets incoming. Obviously, the BLA data, they are filtered by the beacon ID. And then we have the payload forwarded to the TTN console, and we can see clearly the content of our payload, which is correct. And after that, it will be forwarded to Amazon AWS, which will manage this data to write them on a database.